this is MLOps automation level 1. Okay. So as we came through the class in this so far, like few sessions, we have seen like how the MLOps automation level 0 works. So we quickly jump back to the all the things that we did here. So we created a bucket, we installed everything, we created a bucket, and then loaded the data. So we can all see this again, once again we can write these things from scratch. And if you have a GCP console login also, you can also do with me. I can share this notebook, or maybe like, let's say we can write it from scratch also, since most of the people were not able to follow, or maybe like having challenges. Also, we'll cover the basics again, and then we'll cover this session again now. The random forest regressor, what is that? And we'll have to cover a few things, and based on what we got the feedback. Okay. So let me do that, maybe in the next session, because I have to prepare in according to that material and all that things. But yeah, let's say we are, if you have any questions or you want to go in details, let's go there before moving to the Kubeflow, or you want, we can go through the Kubeflow and again come back. So Kubeflow also will cover from the entire basics. So what is your suggestions? How should we go? You need to cover the earlier session in greater detail, or like you want to go with the basics of Kubeflow now? What's your suggestion and comfort?
Bhavesh, yesterday, whatever you do, whatever you have done, just give us a little bit of a brief of that's.
Okay, okay. I think you have not attended, right, yesterday's session?
Yesterday I have attended.
Okay, okay.
Actually, there was bit slow, right? I told you, right?
Mm-hmm. Okay, cool,
So,
cool. Perfect, perfect. Sure. Let me, write a note here as well. So let's say we are writing a new thing. So we'll open this few cells here. Okay, so the first thing that we are load. So I'll write the steps. Okay, so what all we are doing. First we'll write in a plain English language, and then we'll steps for machine learning life cycle. Okay, so first is the becomes the data ingestion. Okay, or maybe like load the data ingestion, load the data from various sources. Okay, so this is like for us, we are doing it from the Google Cloud Storage bucket. Okay, the GCS bucket. This is similar to AWS S3 bucket. So what we are doing is there is a flat file. It is nothing but a CSV file. We are dumping the CSV file in the GCS bucket, and we are consuming it. So far clear on the steps of data ingestion. Okay. Are we clear on the data ingestion, like how we are doing in this problem? Like we are having a flat file CSV. So this is the CSV file. If you go under data, this is our.csv. Okay. If you open this particular file, this is the file that we have. Okay. And we have instant, DT, season, year, month, hour, whatever.
I'm seeing some blank screen. So you are sharing or not sharing?
What others are able to see is it a blank
Yeah,
screen?
we can see that screen.
I can I can see hover.csv file. Yeah.
Okay, maybe I can log off and rejoin. Yeah, 1 minute.
Yeah, hi Mahesh. Were you able to join again back and see the things?
Yeah, I can see now. Yeah, thank you.
Okay, is it visible, the our.csv which we are seeing, the notebook and the our.csv?
Yeah, I can see your screen. Yeah, something left side our.csv, right? 10 years ago. Yeah, past market. Yeah.
Okay, perfect, perfect. Yeah, yeah. Okay. So this is the our.csv when like that we are able to see. This is our data. So in our data ingestion thing, so we'll be having loading the data from the various sources. So our various sources can become like GCS bucket, like AWS S3, maybe something like BigQuery. So how many of you have heard BigQuery? So BigQuery is a popular source which it's a data warehouse. So if you have worked in Azure, it's like Synapse, Synapse Analytics. So these kinds of things will be there. So in AWS, it is RDS or maybe some different things. So these are all the things from where the data can be ingested for a machine learning problem. So in our case, we have taken very simple at the moment, the GCS bucket, the Google Cloud bucket, or maybe the AWS S3. That is our first step. Okay. The second step is our pre-processing. Pre-processing. Pre-processing is nothing but we do some steps for cleaning the data, maybe for cleaning the data that we have, or we want the data in some different shape, or maybe uh, remove the target column. So what is the target column? Target column is the one thing that you are going to achieve. Like say example, in our data set, we had a bike prediction data set. We have to predict the number of bikes that will be required in a particular hour. So our target is the bike count. So in the machine learning language, we tell this like this is a target variable. Okay, so this is our target variable. You see like CNT was there, right? I can just show you again one second. So CNT is the last variable here. So count. So this is our target variable. So or otherwise we call this as this is a dependent variable because this is dependent on all of this, and these are independent variables. Okay. So whatever if you can see from first one to the other things, this we can call as a X and this is as a Y. So this is a independent and this is a dependent variable. So dependent means it is dependent on all the different variables, and this is like independent. Sorry, these are independent, these are dependent. So count is dependent on all of this. That's why we call it dependent variable. Okay, clear. And then we have a target variable. So target variable is nothing but what in our language we have dependent. Okay. Or maybe we can also call it as a Y. So Y in machine learning language. Okay. So this is clear. We can do these steps. So we are cleaning the data or filtering. Okay. We are filtering or we want the data in different shape, because some machine learning models require data in different shape. There is some pre-processing steps like we do the statistical things like maybe standardization, normalization. So these kinds of things, like many things can be there. So for you, it will be the pre-processing will be a block of code. Okay, we don't need to go into the real detail of it. For us, it is a block of code. If it is done by you, you will given the instructions. Okay, do this, do this, do this. But it's certainly like not the case. We don't do much of the pre-processing for the model. But these are like simple like instructions in pandas or numpy or maybe PySpark. Pandas slash numpy slash PySpark. Okay. So far, this is the case. Okay. First step was data ingestion. Second step was pre-processing. The third step we saw model training. Okay. The model training, we have like, say example, you have you have prepared the data now. So in our case, we have, I'll walk you through the code as well. Okay. So this is the data ingestion. So the first one, you say, let me, remove all the, clear all the outputs first. Yes. So, and maybe like we can do this one also. Mark down. But we are going a little slow. Is it okay for everyone now? Or like, shall I keep it more slow, or you want some more explanation? Just keep on giving the feedback.
No, no, this is fine actually because we are into the initial stages, right? So that's fine.
Right. Import where. Okay. So we are doing the import the required libs here. And then in this, I'll just, create a one more like, so that you will be able to understand, which particular section we are having right now. Data ingestion. Okay. So this is our data ingestion. Okay. So we are just doing nothing but we are loading the data from the bucket. Okay. And there was one more thing. I think here we did the data ingestion here. If you see like from this block to this block. So we loaded we loaded a block. This was our data ingestion. We have downloaded the data from internet from a storage API. Okay. This is already a pre-available data set for us. Okay. So this can also come under, so you can imagine this is as a, we can, move this down, this down. Okay. So we can imagine this as a, again, a data ingestion, or we are loading this data. Data loading from internet. The internet is a one another source, okay, or maybe like a public data, we can say slash public data set. So this is like a demo data set for us, okay. So now that we are doing import required libraries, now we did the data ingestion. So data ingestion here, it's like, reading from the bucket. So I'll call bucket now, okay. So I'll not call GCS or AWS S3 bucket, but bucket. It's a simple bucket. We understand the concept, I hope. And then we are calling now reading from the bucket into our notebook. So notebook is the machine like we are using for our coding. Okay. If you are doing this on a local machine, if you are doing this on anywhere, you will load onto the machine. Okay. So that's our second step. Now going to the third step, which we told like a pre-processing. Okay. So this is our data pre-processing. Okay. So this is our data pre-processing. In this we are filtering. So this is a simple, in pandas, you have this logic for filtering. Say example, you have a data frame df is equal to, then you have a, some older df which you want to, so let's call df filter, and then you have a data frame. What you do is, mention all this like in a array, and then you say column 1, CL1, CL2, column 2, column 3, whatever you require, you filter it in this. So this is the same thing. We are filtering only the required columns. Like, okay. So these are some 14, 15 columns are there. So 15 columns we are filtering out of like 17 columns. So we have removed 2 columns. So if you see like, we have not listed down the first 2 columns, the instant and the DTE day. So why we have not listed? Because in machine learning, the machine learning model cannot like understand the dates, cannot make sense of the dates. It needs numbers. So if you split the date in a year, month and hour, like what they have done is they have done in a year, month, and I think they have done weekday. So they don't want a day like 1, 2, 3, 4, 5, 6, but they are splitting it into different information. So that we have done. So that's already present. So this is a redundant information. So in machine learning language, we don't need redundant information, like because this will be of no use for us. Okay, that's why we'll be removing the first two columns. So I'll again write it here. What we are doing, removing the unwanted columns. Okay, so why we are removing? Because the machine learning models don't need irrelevant information or redundant. So if you give redundant information or irrelevant, so it will be causing an issue. Like more than a benefit, it will be harming. That's why we need to remove that. This is the normal, like core thing. So even if you don't have a knowledge, but yeah, I can share right now. And if you have questions, it's your responsibility to ask it right now so that you can get it cleared. If you have like why we do in a certain way, why we are doing that, so you can ask me here only. Okay, because these are all not our part of the core MLOps thing, so we don't need to worry much about it, but you should understand all the basics here so that in your job or maybe in your future thing wherever you have, you should be able to understand. But yeah, if you require any more details, I can definitely cover in a upcoming session, or maybe just give me the feedback. Okay, we know we need more details on the pandas or maybe whatever numpy based on your session. We thought that this is not looking very easy for us. We'll cover. Don't worry. Okay. So are you all available? Like fine, and you're all there with me, right? We can move ahead with this. Okay, perfect. Think I got an thumbs up from Veera. Okay. So far what we have done is filtered our data. Now let's see our data. Like so far we have filtered our data and now we have 15 columns. Okay. So if you see like by that filtering process, we have removed the two columns. That is our the instant and DT day, and we have season onwards everything. No? Season, year, month, holiday, and whatever things are there. So and the last, this is our target column. So we'll say this is our target column. What does the target column mean? Target column mean is like the column which we are going to predict. So machine learning, we have some prediction, right? In the machine learning, there are two types. One is supervised and unsupervised. In the supervised machine learning, which we are doing, we need to predict from already available samples, like learning from already available samples. So we are giving these samples. These are the 17,000 records you are giving, right? These are so many records that you are giving, 17,000. And with given that, given that all this data on the left, you are predicting something on the right. Like you can now understand the partition. Like there is a partition between the last column and between the left of all the columns. So this column is not going into the training. This is so machine learning is means like you give the left column, that's all the left column, that's a x, or maybe we can call this as a y, and then you like give the model to train. So model iterates on this data. Like, for on the first iteration, it will do really bad. On the second iteration, it will do good, good. Like internally, it does the iteration. Okay. Okay. Perfect. So we are here and we know the target, what we need to predict. Okay. This is what we do, and we are running this. Now in this step, this is again, data pre-processing only. Now but it's an important step in the, machine learning. So this is, you can consider this as a separate this thing. So we say splitting the data into train, validate, test set. So in machine learning, for checking. So example, if you ask, if you ask a person to learn something, then you take a test, right? So similar ways in the machine learning. So when you ask a model to get trained, so you give them, so for the training data, let's say, let's hear the picture like what happens. So in the training data, maybe like I'll keep it code only. So what these things I am doing, it's code and markdown. So in a Jupyter notebook, whenever you have a markdown is a format. Okay, markdown is a format that is written, and once you have the markdown format, you can write it in this way. Markdown is a specific format of a file. So we have Jupyter Notebook encodes this thing. So if you keep a code, it will be understood as a code. If you keep a markdown, it will be understood as a markdown. So depending upon the particular thing that you have quoted, it will be particular, like, I think there is some issue with the this thing. I'll just reload it. In the internet connection or something of that kind is there. So it has a certain time. Then again, it will, the connection will die, and we need to make a fresh connection. So because I have kept it loaded in memory from a long time. So every day you need to refresh this once at least. I think we might have lost some things. If not, so yeah, we were here, right? So train test split, and I was saying that why we need it. Okay. So for the training, we give the X, that is all the columns, left columns, and we give Y, that is for us it will be our target variable. Okay, or maybe in other cases, like we can write the name of that thing, C and T. So we'll be giving this, right? So this is there. Count will be there. Okay. So this is our next step. We'll split the training data. Okay. The training data I mentioned, like why we need to split, because we need some data for testing. Like, say example, the training data we have given the X and Y both, but for testing, like, for validation and testing, we only give X as an input, and we compare the Y, both the Y, you know. So this is Y coming from our prediction. This is Y our actual data. Okay. So now in our case, we are having, some 17,000 total rows. So we have done 80, 10, 10 split. 80%, 10%, 10%. So that becomes 100%. So the 80, 10, 10 split, in our case, what will be there? It will be like, some 13,000, 13,500 records. Okay. And then the remaining data will be the, you know like out of this 14,000, like Now I think more 4,000. So 2,000 we can understand it's close to that approximation. So we'll put approximation signs here, thing here, and I think so. If I remember, it was like roughly around 13,900 and then 1,700. Okay, and then roughly around 1,700. If you see, like close to, we are having the same number now, 17,000. So we'll be having like this split. So for this split, the 13,900 will be our training set. The training set will go into the training, like, we'll put X comma Y. So we'll give the X and Y both for training. So in training, we call it as a model dot fit. So this is the function. So model dot fit has both X comma Y. So we'll put both. And for the validation, okay, for validation, we do like model dot predict, or maybe some libraries as model dot evaluate. So we give like only X. So we can call this as X train and Y train. Okay. And then we can call it here X val comma Y val. You are understanding the concept now in this, why we are doing in that way. And we have a testing. And if you have the question, why we have like two kind of things, model dot predict, and here also we can give like X test comma Y test. Okay, so this is how we do. This is how the code will be there. Now we'll go in a code also. And also, if you have any questions in this splitting code also, we can explain that also. So this we are using NumPy. You know, we
What
are
is the exact difference, Bhavesh, validation and test?
sorry. Can you please repeat? I missed the question.
Yeah, what is the difference, exact difference in validation and test?
Okay.
Why do
What is the difference? That's a good question. Validation and test. So validation is required for the internal valuation or comparison. Okay. So what happens is, in the real world, you will train more than one model. Okay. So like say you have trained 5 different models on the same data set. Okay. So for internal purposes, what you'll do is, you know, so testing is the set which we also called as a holdout data set. Okay. Holdout means we are never going to show this data. Okay. So we are never going to show this data to the model. Like never means we, even for testing purposes, we can use the validation, internal testing. You know, this is known as internal testing. So say example, like once the model has seen the data, right? So if the model is in memory, if you show any data, it will kind of try to remember. So in this, like that's why we need to keep this particular separate. So internal testing, or like comparing two different models, we use test comparison. Okay, the validation is used. So test is like when you are final that you are going to use this model in production. Before that, this is the testing. Okay, so at that point of time, we use this before putting our model production. in machine learning language, whenever you are putting a model in production, you did the final. So, something in a coding, we you do unit testing, in the same thing. So similarly, in this machine learning model, before you put the model in the production, you do this kind of testing. Like, if the scores are good, the scores are good on the test set. test set. So we tend to say that the model will do good in real world. So that's what our intention is. So the model should do good in the real world. That's why we are saving this 10% out of the data. So this can be varying, the percentages can be varying. You can keep like, 0.05. You can keep testing set as 0.15. You can do the changes. So this is your own data set. You can play with it and you can change the percentages. Like, you can keep 80%, test as 15%, validation as 0.05%, or maybe like you can further reduce this to 75 and then increase your 20. So the percentages can change. Okay. But you got like what is the difference between a test and validation?
Yeah. Yeah. Okay.
So in our pipeline, we are having only one model. But in the when you see the actual, pipeline which the people have, they might have like four model, three model, different models on the same data. So you can imagine like here. So imagine like let's say here. So we are having a data set here. So data input. Okay. So we have this another data, another, and then this data input will have like train, validation, and test set. Okay, these three will be there. And like between this train, test, and valid, you will be having three different. Let's say you have like a model one, no, you have a model two, model three. So three different models are there right now. So what will go is what will happen now? You will connect the model to one. You will now connect the model training data to this one. So now you will be training a data. This is a real world scenario which I am saying. So let's say we are doing a regression or maybe a forecasting task. Okay. How many of you understand what is forecasting? So do you understand forecasting or maybe like regression? What is regression? What is forecasting? Are you aware about it or maybe let me know or I can quickly cover it. Okay. Let me know like I can cover it basics only. Okay. So forecasting is nothing but we are predicting some variable, prediction of a target variable ahead of time. Okay. So what we are doing and what is regression? Let's define. Regression is nothing but we are predicting target variable. We are predicting a target variable in a range of numbers. So it can be like the range can be 1 to 100. I mean this is not a fixed range, but yeah, it's a numerical. So it can go to any range. Okay. There is no fixed thing. But forecasting is like, what's the, like, today, the same thing we'll predict today, tomorrow, or maybe day after. So like this, we can predict it this for n number of days. We can predict for a month. We can predict for 2 months. The window can be different. Okay. So not to confuse you, but yeah, just to add up your knowledge. Okay. So this is what the forecasting is. Like now we say we are doing a regression. Okay. So we are doing a regression. We need to find the count of bike rentals given a day of week, given year, given week, given season. So all that things we have to predict. This is our problem statement. So this is a regression problem. Okay. What we are doing is regression. So regression, there are multiple models. So now we are having random forest regressor. Okay. The second model we can have like, XGBoost regressor. Okay. So this is the third model we have a linear linear regression. So say example, you are working in a company who is, selling bike taxis or maybe bikes for rental, and you are predicting. So say you are predicting in a New York City for a particular station, you have a bike rental thing. Or maybe like for in India, if you are in India, you are in Bangalore. So in Bangalore, you have some different regions, you have all the inputs, you are predicting the bike. Okay, that's your job. So that's a company you are working right now. So now you will have to, this is a real world example. Now it will be you need to train. So for training, I will take like roughly, let's say the data input. So the original data that we had is of 3 years. So for the past 3 years, you have input data. Okay. For past 3 years, you have all the different needs, like, which area, which area sold how many bikes, or maybe like how many bikes were rented, which area had how many bikes. So the way we have, right, in this our data set, this is hourly data. You can keep hourly. This is like a hourly, daily. That's a level of data. So you need to see in the regression or maybe forecasting. These are the things. Okay. So you say like hourly. So hourly the count is there with all the different variables, input variables. Okay. So let's imagine we are doing very much same. Okay. So we have like, 3 years worth of data. So what I want to say is, instead of like 3 years data taking entirely for training, what my thought process is to use the first few years of data. Okay. Uh, yeah. So let's say we can take this data set here. So we'll say like how much data set? We'll take 2.5 years worth of data for training. Okay. And then we'll take another, like, we'll take 3 month worth of data, 3 months for validation. Okay. And then we'll take another 3 months of data. Okay. We'll take the 3 months worth of data for testing and validation. Okay. Got it? So now we are having a training testing split. So we have done the split. Now this thing training is going on 3 different models. Okay. Then once we have the training data, we'll use the validation data now. Okay. How will use this validation data? Let's say once we have trained this model. Okay. So after training, you will have to test these models. So what you will do is, I'll just copy this here. I'll paste these 3 models. Okay. Now let's say we put a block. So we'll put a section here. This is our training. Okay. We change the color. Okay. Now this is like training, and now we are having a section which is validating. Let's say we are having green. Okay. So validation will have, so this will go, validation data will go for every model, right? Okay. Clear till here? So validation data will go. Now the 2.5-year training data went into these 3 models. Okay. So these model took like some time and they came back. Now we have a model artifact. We have a model 1 to 3. All the 3 models are there. And then we have a validation data. That is our 3 month worth of data. Okay. 3 month worth of data. Model 1, model 2, model 3. 3 month worth of data. And once we have, we'll compare these models. No? Now we have one more block here, which is compare the models. Will again be a green one. We are now comparing the models. So comparing the models is like, you put there, okay. So what do you compare? But so you compare the performance. Okay. And where does this happen? This will again happen in the validation only. So when you have the 3 data sets, so we will compare the performance metrics. So performance metrics. So we'll have some performance metric, right? Yesterday we saw some performance metric. If you remember, we saw something called as a MAE, or maybe for that matter RMSE, or maybe it's like some, then there are some more metrics. Okay, so we saw all of that. So we'll use this. So say example, model 1, let's say like now draw the performance. So this is performance of model 1. Like performance of model 1 is like MAE is 10. Okay, so MAE, what is this? This is mean absolute error. Basically what does this mean is, when we are predicting, like on an average, if you are predicting like a 50 bike, so out of which 10 is erroneous. Like either you are predicting 10, which is a plus 10, or which you are predicting as a minus 10. Like if it is 50, you are either predicting 40 or predicting 60. So there is an absolute error of 10 bikes. That is a mean absolute error. Okay. Then there is uh, so we saw yesterday MAPE. So these are the short forms. This is again mean, absolute, percentage error. So yesterday we saw like mean absolute percentage error was 0.5. But let's say for us it will be like for 10 it is out of 50 bikes, 10 bikes is like 20%. So it's 0.2 or maybe like 20%. Okay. Yesterday was 0.05. But let's say our model is very bad. So this is like model 1. Similarly, you will have these two metrics. You have a model for performance 2, model 3. I think I duplicated here only. For model 3, and we have another one which is a for performance model 2. Okay. So now we have performance for model 2. Here it is. Okay. Let's say the performance for model 2 is like 5, and the error percentage is 0.1. This is like having a almost double. No, the error percentage is 0.4, 40%. So which model do you think is working better?
Model 2.
Yeah, and why that is working better?
The training method is something different in XZ.
XG boost, yeah. So the the training might be different in the model. So like different learning has done. But if you see, well, like we have done now that validation. Like this is not a real word. So this is like a one of the checks that you have done. Now what you do is you go, you tell your system, we think the XG boost is doing really good, and we have compared the performance metrics. Now model 2 is the best. So what we do is have a model 2, you deploy the best model. Okay. But what if like we need to test it? So we need to test. So there is the testing data available. So what you do is you take this model before deployment. Okay. Before deploying the best model, after you compare the results, right? After the comparison of the result, there is one more test data set. You test this particular model 2. Okay. Model 2 on this particular data. So you test this here, like test the model 2. That's the best performing model on our test data. That's coming from here. Okay. You can see this. This is how a real world things work. Like because we need to keep something for testing. So
Yeah,
what we do,
Bhavesh, I agree your point. As per model validation, model 2 is best. Once model 2 after model 2, we'll try to test model 2 and we'll deploy it. Yeah, that is fine. But usually, let's say in our environment, we have 8 models. So every model having own identity and own purpose, right? Why we are comparing one model with another model? So you don't need to compare every model having unique predictions, right? We don't need to compare other models with one model.
no, this I'll tell you. So these models are not the models which are doing a different task. So I think you are getting confused. So there can be, I'll tell you. Let me tell. So this is like count of like a bike prediction, okay? But in your company, you might be having 8 different models for 8 different particular work, okay? You might be getting the final version. This is what I am walking through, the process that a data scientist and a team of data scientists and MLOps follow. Okay, so even I am working, in a problem statement where we have n number of different models. But for each problem statement, you can have multiple different models. So our problem statement is very clear here. So our problem statement is predicting bike count. That's a very good point that you brought. That will give us a real world again,
Yeah, I
question.
got it. Okay, I got it now. Okay. So let's say there is a model. The purpose, the model you are validating, right? Like, let's say a random forest regression. So like random forest X boost, what will you do in that validation? Like, what exactly you are trying to find out? How can we differentiate in that really, like, practically? You're running any code, or how we are validating?
Yeah, that will cover. So I think what's your question is, how will we validate, right?
Yeah, let's say your model purpose problem statement you explained, right? I got it. So my model is, data scientist developed the model. It is working fine, and predictions also is working as expected. Then, like, where this phase will be came into the picture, like, your validation will be done by data scientist, right? So which phase this validation we need to brought up?
Sure. So, there are different phases. Like, say, example, there is a experimentation phase. Experimentation phase, we don't have any model. The data scientist is coming up with a new model. Okay. So, data scientists will themselves do these things. So, if you imagine here, you are here, let's say, MLOps level one. So, this thing, right? If you see the orchestrated experiment, this a data scientist is doing. So what our job as a MLOps will be to automate the same thing, but the task will be the same. Okay. So the task will be the same. Like, data scientists can also do, you can also automate. So for the first time, whenever the data scientist will do, they'll do some manual work like we are doing in the notebook. For the second time or third time, whenever the new models are trained, you can train for a one single purpose, you can train n number of models. That is what we are seeing. So in real world, this happens, like, you train n number of models, like, different models for a single purpose, like, for a purpose of predicting the bike rental given, and all this input. So this, so I was trying to come to your question which you mentioned, right? Say example, in Uber, we were, demand checking the taxi demand prediction. So in taxi demand prediction, so in Uber, say example, you are in working in Uber. So if you say in Uber, they have a taxi demand prediction, but for this taxi demand prediction, you have so many different things. You, like, find the best route. Okay. So there will be, like, again you will be having uh, get a driver assigned. So they'll assign the best driver. Okay. So they'll, this is for an entire ride. For a one single ride, you will have a, this is not a demand actually, for taxi flow prediction or something of that kind. So this one task, like, you booking a taxi. So like example, Uber booking a taxi flow. So for when you click a button, in your application, there are so many, like, if you put a, like a location, like if you put like one location to another location, so all these models and different flow will kick in. Okay. Predict the price. Okay. And then this can be the, so you can touch one model here. So you can inference, you can get predictions from models. Okay. At that point of time, this will not work. This will not work. That will be only like one model. Okay, which is this one, the final one, right? The one thing. But before this, Uber does this. They might run this particular pipeline. This is a pipeline. This we call as a training pipeline. Okay, this particular pipeline is there, right? Which I shown you. Sorry, this particular pipeline is there, which we call as a training pipeline. Okay, you're getting that. So there is one particular. This is a training pipeline. So this can run, like I can run this weekly once, I can run monthly once based on how many years of data. So this is my final model, okay. But the output is that deploy one model. So as a final, like what I get as a data engineer, or maybe what will be my output as a machine learning engineer, I'll get deploy the one best model for the one purpose. Now you get like why you can see only one model, but at the background this all happens. Like there will be n number of different models, okay. Are we good here?
So choosing the best model, everything will taken care of MLOps, right? If we
Yes, yes.
automate this.
Yeah, exactly. That is our job.
Oh, right.
So,
Got it.
so this is why we have training pipeline. So training pipeline can run, this have a cadence. Okay. This can run, maybe like what we say, maybe you run this once a week, maybe you run this once a month, depending upon how frequently you plan to train. This is a schedule. Okay. We call it as a schedule. This is a scheduled one, but we have a on demand as well. So there is a on demand, there's some system change, some data change. So data change can also trigger the pipeline. So we can call this as a triggers. Okay.
What is that training meaning? A little confusion. What is the uh, training of model? What is the
So
development of model?
yeah. So training or development of model is nothing but you take the input data, you put the model on training. Like there is some like in the machine learning, some mathematics happen at the back end, and out of this mathematics, you will get out some parameters, the final parameters, output parameters, which you will save. We'll save this output parameter. So in every model training, you will get some output parameters, which are the final crux of the model. So for every particular model, for one model, two model, three model, you will get output parameters. Okay, this is what the training means for us. Okay, so we have a model which is having some data set, which is training the data set, taking in the data set, doing the mathematics, and then getting us the output parameters. So now you don't need to worry much about the mathematics of it. Okay. And this output parameters we serialize. We serialize it in a file, in a file. So this is what we add. So in our case, we are using some pickle file. So this is a Python default serialization. Okay. Pickle file. We have another file such as joblib. So for XGBoost model, right? For every model, you have a particular way of doing that serialization. In TensorFlow, we have a protobuf. So this will be coming all. We'll be learning this. For now, you got it right. There are some output parameters. We serialize it in a file. And then we store this in a model registry. In the GCS location, bucket, and model registry. Clear? This is your for your questions. Any questions on this so far?
Yeah, Bhavesh, I got your thing. Thing is, whatever models are developed by the data scientist, before deploying into the production, we will have MLOps team or MLOps engineer. We will have one training pipeline should be developed by our team, and whatever model they are given. So we should have take their model and we'll have to run pipeline on top of their model and try to come to the conclusion. This is the model. We'll have a best model and we'll try to test it and we'll try to deploy it, right? That's what we'll try to cut the conclusion purpose. We we created training pipeline. That's what my understanding is correct.
Absolutely correct.
Oh,
Yeah. So we are onto this. So like this is how, if I go in detail, this will how be the class. I started from here and get the questions, and I'll have to explain the every depth of it, and then we'll have to move ahead. And then this is all the coding part. So here what we did is all the visualization part. I visualized the process. So of the training pipeline, I built from scratch, like how the training pipeline looks like. Okay. And here we are now looking at the code. So the code is different, and then understanding this thing is a different. So you need to understand both of it. Okay. Now we will be able to communicate like better here. Like X train, what is the I X train, Y train? We have X valid, Y valid. We compare the data, the input data. Okay. Shall we go ahead, or like how it is? You want to
Yeah,
complete this till here, till this part, like more 5 minutes, 5 to 10 minutes, yeah? Shall we complete it here? Or like you have some other commitment?
we'll see tomorrow. It's already overloaded in the ways. Okay.
Cool. Okay, no worries.